The next important topic is the method of variation of parameter, which is one of the most important topic of your differential equation with constant coefficient. And this method is known as what? General method. Okay. So method of variation of parameter, variation of parameters, parameters here. Now we first consider the linear differential equation, linear differential equation with constant coefficient, with constant coefficient, coefficient, that is what? Coefficient of second order, of second order. Okay, so that is d square y by dx square and plus m dy by dx and plus l y and equal to what? X. Okay, so this is the second order linear differential equation. Okay, we know the complementary function. What is the complementary function? Let let yc equal to c1, yc equal to c1 y1 plus c2 y2 be its complementary function, its complementary function. Okay, where c1 and c2 are arbitrary constant, where c1 and c2 are arbitrary constant, arbitrary constant. Okay, so let us assume that the particular integral is given by, so assume that assume that particular integral is given by yp equal to what? uy1 plus vy2, where u equal to negative of integration y2 into x divided by w dx, and v equal to integration of y1x divided by w dx. Okay, and and when w equal to y1 y2, w equal to determinant of y1 y2 and y1 dash means derivative of y1 and y2 dash derivative of y2 dash, and this equal to y1 y2 dash minus y1 dash and y2 dash, and this must not be 0. Okay, then 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 you can say that y1 and y2 are two linearly independent solution of given differential equation. Then y1 and y2 are two linearly independent solution of given differential equation star. Okay, given differential equation star. This is the differential equation name as star. Okay, therefore the complete solution is given by, therefore then y1 and y2 are two linearly independent solution of given differential equation star, and w is known as what? Functional, and w, this is what? Function of x. So you can write w of x. W of x is known as Wronskian. 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 Okay. So w of x is known as Wronskian. Getting Wronskian of y1 and y2. Okay, Wronskian of y1 and y2. So Wronskian if either identically 0 or never be 0. Okay, if Wronskian is not equal to 0, then you can say that y1 and y2 are linearly independent solution. Okay, so thus the complete solution is given by the complete solution is given by y equal to yg. Complete solution means general solution yg. So first one is write down yc plus yp, which is require complete solution of given differential equation. Okay, so this is the method for different linear differential equation with constant coefficient of second order. Okay, so similarly you can have of third order. Okay, let us take the problem.
Yes, sir.
So this method is known as general method. You can apply this method on any problem of the linear differential equation with constant coefficient. Okay, now let us solve the problem. Example number 1. Solve the differential equation d square minus 1 y equal to 2 divided by 1 plus e raised to x. We have to solve the given differential equation. So solution, first of all we will copy the given differential equation. We write given differential equation. What is that? D square minus 1 y equal to 2 upon 1 plus e raised to x. Okay, now our job is to find out the auxiliary equation. Therefore for complementary function we put here d square minus 1 equal to 0. So we can write the auxiliary equation is given by what is the auxiliary equation? This is d square minus 1 equal to 0. Okay, so we will have the two roots of this. So this gives, we will have two factor d minus 1 and d plus 1. Okay, so roots will be what? D minus 1 and d plus 1, and this equal to 0. So you will get d equal to 1 or minus 1. Getting? So therefore the complementary function is given by, therefore the complementary function is given by What is the complementary function? Yc equal to so roots are distinct, so we will write c1 e raised to x and plus c2 e raised to minus x. Okay, this is the complementary function where you can write y1 equal to e raised to x and y2 equal to e raised to minus x. Okay, so this is the first term is y1, second term is y2. Getting? So just observe your complementary function yc equal to c1 y1 plus c2 y2. So from this we will get y1 and y2. Okay, so your right hand side, our right hand side is what? X equal to 2 upon 1 plus e raised to x. So to find a particular solution, we first find Wronskian. Okay, so to find particular solution, or particular integral. Okay, we first find w of x. So we know that what is the w of x? We know that w of x, that is Wronskian. Wronskian can be written as well. This is the order up to. So we will have determinant up to order 2 only. So y1, y2, derivative of y1 and derivative of y2. Okay, this is the formula for w of x. Now put all the values over here. So w of x equal to determinant y1. Y1 is what? E raised to x, and y2 e raised to minus x, and derivative of y1. Derivative of y1 is e raised to x, and derivative of y2 is minus e raised to minus x. Okay, now we find the determinant of this. Just cross multiply. So we will get negative e raised to what? E raised to x into e raised to minus x. Okay, so minus sign put over here, cross multiply, so e raised to x into e raised to minus x. Okay, so this can be written as this equal to, base is same, the power will be added, so this equal to what? Negative of e raised to x minus x become 0, and minus e raised to x, base is same, the power will be added, x minus x is 0, but e raised to 0 is what? 1. So this is minus 1, and which is equal to minus 2, and this is not equal to 0. So we can say that y1 and y2 are two linearly independent solution of given differential equation star. Therefore y1 and y2 are two linearly independent independent solution of given differential equation star. Okay, name the given differential equation as star. Okay, so now our job is to find u. Now since we know the formula of u equal to what? Negative of integration y to x divided by w of x, or you can write just simply w. Okay, w और Wronskian, इसको Wronskian बोलते हैं. So this, now this equal to, therefore u equal to negative integration of y2, we will have y2 is e raised to minus x, y2 is e raised to minus x into x. Your x is what? Your x is 2 upon 1 plus e raised to x. So into 2 upon 1 plus e raised to x and divide by negative of 2 function and dx. Okay, and dx. So negative negative become positive. Okay, this uh, positive and 2 will cancel. So this become integration of e raised to minus x divided by 1 plus e raised to x and dx. Okay, now we will integrate here. Now how to integrate? So we will integrate by putting this function e raised to minus x equal to t. So we put e raised to minus x equal to t. Okay. Uh,
Yes.
so just differentiate this. So this implies that negative e raised to minus x dx, and this is equal to what?
80.
dt, and that is e raised to minus x dx equal to negative of dt. Getting negative of dt. Now what? We have to find out. Now substitute this value over here. So therefore u equal to integration of e raised to x dx is what? We write negative of dt, and divide by 1 plus e raised to x, but here e raised to minus x. So for this what I have to do? Here just do the calculation sum. Since e raised to minus x equal to t, so this implies that 1 upon e raised to x equal to t. So this can be written as what? This e raised to x equal to what? 1 upon t. Getting? So e raised to x 1 upon, so e raised to x become 1 upon t. Just substitute this. Just substitute. So this is 1 upon t. Okay. Now integrate it. So this equal to negative I'm taking outside. So integration of dt cross multiply. So t plus 1 and divide by t, and this t go on the numerator. Okay. So this become like this. So this can be written as in minus integration of this. Now here we have to do some adjustment. Okay. So we write here t and plus 1 and minus 1. Is there any change in the numerator? Is there any change in the numerator? Yes or no?
No, sir.
No. Why is this so? Because I'm adding 1 and subtracting 1. Okay, now separate it. So now separating this. So integration of, separate this. So this become t plus 1 by t plus 1 and minus 1 upon t plus 1 and dt. Okay, so this can be written as negative of integration. This one t plus 1 and t plus 1 will cancel. This become 1 and minus 1 upon t plus 1 and dt. Now we can integrate it easily. So this is minus integration of dt, multiply dt inside, integration of dt will be t, and minus integration of 1 upon t plus 1. This is 1 upon x. So integration of 1 upon x is log of x. So just write down. So this become what? Log of t plus 1. Okay, log of t plus 1. Now we will resubstitute the value of t. What is the t? T is what?
E raised to minus x.
E raised to minus x and minus log of t. T is e raised to minus x. E raised to minus x plus 1. Okay, this is u. Similarly, we have to determine v. Now let us go for the next page. Now we find v. Since formula for v is equal to integration of y1x divided by w and dx. Okay, just substitute all the values over here. Integration y1, y1 is what? Y1 is e raised to x, and x, your x is what? 2 upon 1 plus e raised to x, and divide by w. W means function. Function is what? Function is minus 2. Okay, and dx, and these two will cancel. So we will have in this equal to minus integration of e raised to x divided by 1 plus e raised to x. Okay, now see here. So, and into dx in the denominator. So we will have, on numerator we have derivative, in the denominator we have the function. So नीचे function ऊपर derivative, so we will write log of function. Log of function, which function? Your function is what? Your function is 1 plus e raised to x. Why is this so? Because we will have the integration formula. So we have the integration formula, f dash of x by f of x and dx. So this formula is what? So नीचे function ऊपर derivative, so this become log of function. Log of function, that is f of x. Okay, so this is formula for integration.
Yes.
Now, therefore the particular integral is given by the particular integral is given by integral is given by yp equal to u y1 plus v y2. This is the formula for particular integral. Now we found the value of each term. So this equal to yp equal to u. What is the u we found here? U is what? Negative of, can you tell me? U is negative of, we putting a bracket, negative of e raised to minus x, e raised to minus x minus log of e raised to minus x and plus 1. Okay, this is u, and but what is the y1? Your y1 is e raised to x, okay, and plus v, your v is negative of 1 plus e raised to x, so we write here minus, so minus log of 1 plus e raised to x into y2. Y2 is, your y2 is what? E raised to minus x, e raised to minus x. Okay, so this is your particular integral. Now just multiply inside the bracket, or don't multiply. Therefore the complete solution is given by, therefore the complete solution is given by, complete solution is given by, what is the complete solution? Complete solution, that is y, and this is equal to yp, sorry, yc plus yp, yc plus yp, and this equal to, your yc is, we found here, what is the yc? c1 e raised to x plus c2 e raised to minus x, and plus particular integral minus, I'm writing this, so this is e raised to minus x and minus log of e raised to minus x plus 1 into e raised to x and minus log of 1 plus e raised to x into e raised to minus x. Okay, so which is the required general solution of your given differential equation? or you can simplify this by multiplying. So just simplify one more step. So this is what c1 e raised to x and plus c2 e raised to minus x. Okay, minus, I'm multiplying e raised to x and minus inside. So this become what? So e raised to minus x into e raised to x. So this become e raised to 0. But e raised to 0 is 1. So just write down e raised to 0 minus minus goes plus. So e raised to x log e raised to minus x and plus 1 and plus 1 and minus e raised to minus x e raised to minus x log of 1 plus e raised to x. And write down one more step, and this equal to c1 e raised to x plus c2 e raised to minus x. But e raised to 0 is what? Minus 1 and plus e raised to x log of e raised to minus x and plus 1 and minus e raised to minus x and log of 1 plus e raised to x. Okay, so this is your required general solution, or you can say complete solution of given differential equation by using variation of parameter. Okay, I hope you understood this method. Have you understood this?
Yes, sir.
Very simple. So let us go for the next page. So what is the third order formula? If you have the differential equation, consider the differential equation of degree 3. Consider the linear differential equation with constant coefficient of degree 3. Degree 3. What is the degree 3? We write the linear differential equation with constant coefficient of degree 3. So dq y by dx q and plus m d square y by dx square plus n dy by dx plus ky, and this is equal to x. Okay, so this is the linear differential equation with constant coefficient of degree 3. So you know very well how to find the complementary function. So the complementary function is given by the complementary function CF is given by what is the CF? This is yc equal to c1 y1 plus c2 y2 plus c3 y3. Okay, let us assume that the complementary function is given by this thing. Okay, so let us assume that the particular integral is, so assume that the particular integral is given by yp, given by yp equal to uy1 plus v y2 and plus w plus w uvw y3. Okay, y3. Now we have to determine the function. Where u, v and w is what? So where u, the formula for u is integration of y2 y3 dash, means derivative of y3 minus y3 y2 dash. Okay, means derivative of y2 into x and divide by w. ये कैपिटल है, ए डब्ल्यू और ए डब्ल्यू में फर्क है. दिस इज द कैपिटल and dx. Okay, and v equal to integration of y3 y1 dash minus y3 dash y1. Okay, so y3 into y1 dash minus y1, इसको इस तरह से लिखेंगे, माइनस y1 into y3 dash. Okay, into dx into x and dx divide by w, capital W, divide by w. Okay, now w, small w, equal to integration of y1 y2 dash y1 y2 dash minus y2 y1 dash into x dx and divide by capital W. ठीक है, divide by capital W. This is the formula for u, v and w. And where w, what is the w? Capital W. Capital W is determinant of order 3, y1 y2 y3, and derivative of y1 first, derivative of y2 dash, derivative of y3. So here derivative of y1, that is y1 dash, derivative of y2, that is y2 dash, derivative of y3, that is y3 dash. Now we will take another derivative. We will take another derivative of this. So derivative of y1 is again, that become double dash. Derivative of y2 is again derivative of y1 dash. So we'll take derivative of y1 dash. So this become y1 double dash, and we will take derivative of y2 dash. So this become y2 double dash. Similarly for y3, derivative of y3 dash, that is y3 double dash. Okay, and this determinant must not be 0 while solving this. So this determinant must not be equal to 0. Then you can say that y1 y2 and y3 are three linearly independent solution of the given differential equation star. So name this equation number star. So therefore y1 y2 and y3 are three linearly independent solution of given differential equation star. Okay, thus the complete solution or you can say general solution, complete solution is given by y equal to yc plus yp. Okay, so this is the method of third order linear differential equation with constant coefficient of variation of parameter. Okay, I hope you understood this formula or this technique, how to solve the given differential equation with constant coefficient of degree 3 by using method of variation of parameter. Okay, got it?
Yes,
Yes,
sir.
sir.
Yes, sir.
टाइम ज़्यादा हो गया क्या? 3 मिनट 2 मिनट? चलिए ठीक है, आज के लिए यहीं पे समाप्त करते हैं, फिर नेक्स्ट टाइम मिलेंगे तो इसका और आपको एक्सरसाइज दूंगा. इसका प्रॉब्लम दूं क्या एक्सरसाइज के लिए? एक दो.
हाँ सर, दे दो. डिग्री 2 का देना सर.
डिग्री 2 का चलो
हाँ सर.
लिखो. हाँ, एक दो ले लो तो ज़्यादा अच्छा रहेगा. एग्जाम्पल सॉल्व नंबर 1. d square plus 1 y equal to x sin x, x sin x. Number 2, solve d square minus 4d plus 4 y equal to e raised to 2x by x. Okay, बस ज़्यादा नहीं. By using method of variation of parameter. Okay, take it HW. चलिए, आपका लेक्चर हो चुका है ना, इसके लिए मैं आपको 2 ही दिया. बाय यूजिंग मेथड ऑफ वेरिएशन ऑफ पैरामीटर, सेकेंड ऑर्डर का ही दिया मैंने. ठीक है, चलिए.
Yes, sir.
हाँ, ओके, नाउ यू कैन लीव दिस मीटिंग. Thank you all of you for joining to us, and we will meet soon in the next lecture.
Yeah, sir. Bye, sir.
Bye.
Thank you, sir.